I am Christine Largeron from Ubercurien Laboratory at University of Saint-Étienne, and I'm going to present a work entitled Linking the Dynamic of User Stance to the Structure of Online Discussions. This work has been done in collaboration with André Mardal from the same university and André Rizoyou from UTS in Sydney. Nowadays, online events are increasingly shaped by the discussions occurring on online social media. For instance, the outcome of significant events, such as the presidential elections in the United States of America or the decision of the United Kingdom to leave the European Union, influenced by the opinions that voters formed, notably on social media. Such contentious subjects lead to polarized opinion. The prevailing theory is that online polarizations emerge due to filter bubbles which only expose users to peers with the same views. This led to a body of work that believes that online polarization can be addressed by exposing users to contrary news and views. However, other participatory studies conclude that exposure to opposing views on social media could increase polarizations. Thus, the dynamic of opinion formation and polarization in social media is an open problem that we decided to study in this work. More precisely, we addressed two open questions. First, we wondered if the stances of users concerning contentious subjects are influenced by the decisions they are exposed to. More precisely, we are interested in the dynamic of polarization. Previous work concentrates mainly on detecting and forecasting opinion polarizations based on the content sent by the users. On the opposite, our work concentrates on detecting polarizations dynamics by focusing on the interaction between the users. The second question that we would like to address is the following. Can we predict the future stance of users based on their present activity and particularly their interaction on social media? And what are the factors that influence the change of stances? To answer these questions, we consider as the context of Reddit discussions around Brexit. And in this context, we can distinguish three stances for our users: against Brexit, pro-Brexit, or neutral. And of course, a user can change of stance over time. More precisely, we built a longitudinal dataset containing discussion around Brexit on Reddit, spanning from November 2015 until April 2019. We have divided the whole period into 15 intervals based on the occurrence date of real events, such as the UK referendum of June 2016, the nomination of Michel Barnier as chief negotiator, or the beginning of the Brexit negotiations. We split also the whole dataset into 15 subsets according to the time interval in which they were posted. All these datasets are publicly available. The left side of this figure shows an example of a real Reddit discussion containing or beginning by an initial post N0, and we have then 5 comments N1, 2, and 5, 6, N1, 2, and 5, sorry. For instance, comment N3 is a reply to comment N1. This discussion can be represented by a tree structure as shown on the right side of the figure. From this representation, we defined several features that we use to predict the future stance of a user. We introduced 3 sets of features to capture different aspects of the user activity. The first one describes the user activity at the global level. The second one describes his activity per stance. And finally, the third one focuses on the structure of the diffusion in which is involved. More precisely, to describe the activity of a given user during a time interval, we consider in the first set of features the number of posts and the number of comments that is sent during the period, as well as the number of replies generated by his activity. The second set aims to capture how the user interacts with users of different stances, against or pro-Brexit or neutral. For that, we consider the comments sent by the user during the period in response to entries posted by each group. And we consider also the number of comments he received from each group in response to its entries during the period. Finally, the third set aims to capture the type of thread in which it takes part. For that, we consider the discussion in which the user is involved during the period, and we count the number of comments submitted by each group in these diffusions. We decided also to build a fourth set of features corresponding to the union of the three previous ones, as well as a set of textual features that we built from the content sent by the user and denoted F01. This set of features correspond to a baseline that we can exploit in our experiments. These feature sets correspond in fact to TF-IDF scores of the 100 top words appearing in the content sent by the user during the period. Finally, the last set of features, union of both relational and textual features. Having defined these different sets of predictive features, we cast the problem of forecasting the future stance of a user as a supervised machine learning problem, in which for each period and each user described by his current stance and his features, we want to predict his stance at the next time interval. One advantage of this methodological approach is that we can compare the predictive power of the different feature sets. However, it presents also a difficulty because we don't know the stance of the user for each period in Reddit, which means that we don't have a training set to learn our model and a test set for its evaluation. To solve this issue, we used a textual classifier trained on another dataset extracted from Twitter, in which we have this ground truth. In other words, we know the stances of the users. And so from this previous model learned on Twitter, we apply it on our own datasets. By this kind of transfer learning, we have been able to assign to each user a stance for each period, in addition to the values of the features previously described. We learned and tested 5 different algorithms: logistic regression, KNN, random forest, gradient boosting, XGBoost. We evaluated this model using a double cross-validation, including the tuning of the parameters. We measure the performance of the models using F1 score, accuracy, precision, and recall. However, the results obtained according to this last measures are only available in our supplementary material. By this way, we can compare the performance obtained using the different sets of predictive features previously defined. The obtained results are presented in the following tables. Concerning the relational features FS1 to FS4, we can see that the best performing classifiers are random forest and XGBoost. We can also observe that for most classifiers, the performance improves from FS1 to FS3, confirming that the discussion in which the user is involved best indicates his future stance. We can also notice that for the best performing method, relational features, FS1 to FS4, have higher predictive power than textual features, denoted FS0. Moreover, using textual features together with relational features does not improve results significantly. We decided to analyze in more detail the performance of the best classifier, SGBoost, on the best feature set, FS3, and for that we computed the prediction performance for each combination of present and next tenses. The results are given in the table. We see that the classifier performs well for the user who maintains their opinion between two consecutive time frames, as we can see on the main diagonal of the table. Noteworthy, it also performs quite well for the transition from neutral to pro or against Brexit stance. This result implies that we can predict the of the currently undecided participants in online debates. However, the model needs to be improved for predicting the transition for users having more extreme opinions. To conclude, in this work, we have collected a longitudinal dataset containing discussion around Brexit on Reddit, which is available online. We designed several sets of features to describe and analyze the dynamics of opinion formation and polarization. Using a supervised machine learning approach, we have shown that the stance of a user depends on the stance of the user in interaction with him. In this work, we were faced with the lack of ground truth, namely the stance of the users, and for this reason, in future work, we would like to obtain such labels using crowdsourcing. And we plan also to build other feature sets. Thank you very much for your attention, and we will be happy to reply to our questions.